Section 5.4, we're looking at differentiation of exponential functions. And we're only going to be looking at the e to the x function. We know that there could be other bases, but we're not going to be covering that. And the derivative of e to the x is itself. It's just e to the x. So if I had y equals x squared e to the x, I know I need to use the product rule. So when I take this derivative, y prime, it's going to be x squared times the derivative of e to the x, which is e to the x, plus e to the x times the derivative of x squared, which is 2x. And we can clean it up a little bit. But that's pretty much it for that derivative. Another example, and this is taken from your notes. So I have g of x is e to the x plus 7 to the 1/2 power, or it could have been written as the square root. So when I take that derivative, I'm going to use the chain rule, so the 1/2 gets multiplied out front, e to the x plus 7 to the negative 1/2 power, because you have to subtract 1 from the exponent, and then take the derivative of e to the x plus 7, which is just e to the x. And again, we can clean that up so that e to the x is the only thing that's in my numerator, and the denominator I have 2, and then the square root of e to the x plus 7. So if I have an actual function and I take that derivative, then I'm going to be using the chain rule. So the derivative of e to the f of x is going to be e to the f of x. Again, it's its own derivative, but I also have to take the derivative of that, whatever that function is. So it's going to be times f prime of x. Alright, so you're going to rewrite it and then take the derivative of whatever that exponent was. So some examples. We have y equals e to the x squared. So I take y prime, and it's just e to the x squared, and then derivative of x squared is 2x. So y prime is going to be 2x times e to the x squared. Another example, y equals e to the negative 5x. So that derivative is going to be e to the negative 5x times the derivative of negative 5x, which is negative 5. I have g of x equals x times e to the 7x. So g prime of x is going to be x. I'm leaving the x and I'm taking derivative of e to the 7x, which is e to the 7x times 7, plus e to the 7x times the derivative of x, which is just equal to 1. So we get 7x e to the 7x plus e to the 7x. Your book publisher loves to factor this, so sometimes they'll express the answer like that. And one more, y equals e to the x over x minus 1. So we have to use the quotient rule. So I have the denominator times the derivative of the numerator, which is just e to the x, minus the numerator times the derivative of the denominator, which is just 1, over the denominator squared. So we get e to the x minus e to the x when I distribute this, minus e to the x, all over x minus 1 squared. Oops, I dropped an x. X e to the x minus e to the x, when you distribute that, minus e to the x. So I have two of those. So it's x e to the x minus 2e to the x over x minus 1 squared.